and welcome to a special virtual edition of NASA Science Live. My name is Dahlia Kirschbaum, and I'm an Earth scientist at NASA. Today marks the 50th anniversary of Earth Day, and while we can't be together due to social distancing practices, we're virtually commemorating this event with scientists and engineers from across the U.S. ready to talk to you about the amazing things that are happening at NASA to study our planet. But first, let's take a moment to reflect and appreciate the one and only Earth.
Earth. Home. Of all the planets NASA has explored, none have matched the dynamic complexity of our own. Deserts, tropical forests, icy poles, massive storms rage over land and oceans. A unique atmosphere protects and insulates us. Liquid water spans its vast surface, and a delicate balance of systems gives way to a kaleidoscope of life. Earth is a very special place. From the vantage point of space, the perspective of sky and sea, and all across the land, we study our planet not only to learn about it, but also to protect it.
On this 50th anniversary of Earth Day, we are finding ourselves in a much different world than we've experienced before. At NASA, we study how our environment is changing using NASA and partner satellites that orbit the Earth high above. For example, we've seen reduced nitrogen dioxide emissions over major cities as a result of changing factory operations. With NASA's suite of satellites, instruments, and models, we are studying our home planet 24 hours a day, 7 days a week, every day of the year. So joining us now to talk about NASA's unparalleled contributions to Earth science is NASA Administrator Jim Bridenstine. Jim, thank you so much for joining us, and how are you doing?
Well, thank you for having me. I'm doing fine. I'm actually doing really well. As you can see, I'm in my home, as many people right now are in their homes, following the guidance of the Center for Disease Control. And we are all a family here. My three children are out of school. I've got a 14-year-old, a 12-year-old, and an 8-year-old. My wife is here, and my mother-in-law lives with us. We have 2 dogs. And as you can see, my living room is now the NASA headquarters. What I'm hoping is during this interview, we won't have any maybe screaming kids or dogs barking, but we'll see how it goes. But I will tell you, the NASA workforce across the entire agency, a lot of people are working from home, and it's not easy, especially when kids are out of school, and spouses are working from home at the same time. So look, I know there's a lot of challenges out there, but we've got a lot of very important missions going forward. We do have mission essential functions that we're continuing to work on as an agency. And of course, we have this really unique opportunity to study the Earth right now during this pandemic when, production across the globe is down, and we're able to learn things that otherwise we might not be able to learn. So we definitely want to get this pandemic behind us. We definitely want to get back to our normal ways of life. But in the meantime, this is a really unique opportunity, and so NASA intends to take advantage of it.
Well, thank you so much. And really talking about how NASA observes the Earth, looking back over the last 50 years of Earth Day and 60 years of NASA Earth Science, what do you see as some of the most important discoveries?
Well, NASA has really a very unique perspective when you talk about looking at the Earth from space. And we're always sensing the Earth in all parts of the electromagnetic spectrum. And we're able to look at the different parts of the Earth system specifically, and then make an effort to see how they affect each other. So the lithosphere, which is of course the study of the land, and the hydrosphere, which is the study of the water, and the cryosphere, the study of the ice, the atmosphere. All of these different spheres that make up the Earth system are all very, very important. And we're starting to right now understand how they feed into the whole system. We think about, we see the oceans rising and we see the ice melting. And how does that affect, how the climate is changing? We know that the ice reflects the energy from the sun, and we know that the ocean absorbs energy from the sun. And so there's a feedback mechanism there where we're actually seeing the warming exacerbated by the melting ice. At the same time, carbon dioxide is a greenhouse gas, but it's also used by plants for food. And so we're seeing in a lot of parts of the globe, we're seeing a greening of the earth. And the greening of the earth has a feedback mechanism that actually works in the opposite direction against the global warming that we're seeing. So some of these feedback mechanisms have a longer delay. Some of them are immediate. And really, what we're doing right now as an agency is trying to understand it. I guess the important thing is we need to acknowledge how much we don't understand, and that NASA is exceptionally unique in its ability to learn what we don't know. And there's so much left to do. What we're learning every day is how much we don't know. That's what we're learning. And NASA is in this unique position to get us a better understanding so that we can move forward with better models. Sometimes, these models, they're all over the map, especially if you get past 5 years. We want to get better modeling so we know kind of what the future holds and how we can respond to it. And certainly the only way to get better models is to get more data and feed that data into the models. And NASA is uniquely positioned to do these activities. And here on Earth Day, these are things that we want to highlight that NASA is uniquely situated to do.
Well, you highlight just these complex systems and the role of satellites not only looking into the solar system, but also pointing right down at Earth. So if we take a question from social media, from Being Sujith on Instagram, they're asking specifically about the ozone layer. And they ask, is it really healing? What do we know? What is NASA's satellite data and models telling us about the ozone layer?
Absolutely. So, NASA has been at the forefront of this issue now for decades. And of course, following the Montreal Protocol, what we are now seeing is that it is in fact working. And as it works, we need to continue working the Montreal Protocol. I will tell you, one of the challenges is not all nations on the planet, even though they're signatories to it, they don't always follow it. I'll tell you this, NASA is uniquely positioned to be able to quickly identify what nations are not following it, call them out, and mitigate those challenges. But we know that the ozone layer is healing, and over the course of time, it will heal even more. And because of what NASA is doing, all of humanity will be better off.
Well, thank you so much for joining us. I think, one last very quick question is, what's for the future? What are you excited about at NASA looking forward for Earth science?
I'll tell you, I get really excited about a couple of very important things. We talk about the population of the globe increasing, and how are we going to feed these increases in populations all over the world. NASA has a lot of science capabilities in orbit around the Earth. Like I said, we're looking at the Earth in every part of the spectrum, and of course making determinations about how we can improve lives. One area where we're seeing some significant progress is increasing crop yields. We're using Landsat 7, for example, to make measurements of what we call evapotranspiration, which is basically a measurement of how much moisture is being evaporated from the soil and how much plants are transpiring, or think of it as plants breathing. And we can come up with a precise measurement down to 1/4 of an acre to help farmers very precisely figure out how to irrigate, down to 1/4 of an acre. And what we're finding is that by doing this, farmers are able to increase crop yields while reducing water usage by about 25%, and at the same time preserving nitrates in the soil. And that's why the crop yields actually go up. So we're very excited about using NASA's earth science capabilities to increase crop yields, preserve the environment. Those nitrates, that's a pollutant. When it gets in the water supply, then we have to clean it out so that we can actually drink the water. That's very expensive for state governments and municipalities. And so if farmers can more precisely irrigate and increase crop yields, save water, preserve nitrates in the soil, all tremendously important. And then we're using the International Space Station. We're testing a mission we call eco-stress. So we can actually measure the stress on a plant based on how much irrigation it's getting. And you know, every plant has stomata, which breathe. Think of how a plant breathes. And those stomata, when the plant gets stressed, it's not getting enough water, that stomata closes. And then the temperature of the plant goes up. Well, we can measure the temperature of the plant from space. And we can determine if a plant is stressed weeks ahead of when a farmer would know. And the farmer can then respond and irrigate or maybe provide fertilizer or something that the plant needs. These are all things that are second and third benefits to what NASA has been doing on the Earth side for many years. And then, of course, I'm really excited about a mission called GRACE, which is helping us understand how the gravity of the Earth changes. If you can imagine that, wherever you are on Earth, the gravity is a certain amount. Depending on where you are, the gravity is different. I know that sounds strange. We don't feel it. It's very, very small. But it's based on how water moves around the Earth. And we can make determinations as to, whether or not aquifers are full and how much water is going to be available into the future in different parts of the world. So NASA Earth Science is just doing amazing work. It's improving lives. We're better able to predict drought. We're going to feed more of the world than ever before. And we're going to get a better understanding of how our human activity is affecting the climate so that in the future, policymakers can make really good decisions. So here on Earth Day, I would just like to encourage everybody to know and be aware of the great work that NASA is doing, and we will continue doing it. Our Earth Science budget today is higher than it's ever been in history. And in fact, and that's because of the great work that's being done, and we're learning so much all the time.
Well, thank you so much for joining us, Administrator Bridenstine.
Well, thank you for having me. It's been a pleasure.
Well, we really enjoy hearing how, we can connect the satellites all the way to the field scale and how this is so important for studying our home planet, Earth. Now, many of you may think of just NASA as space shuttles and maybe satellites, but you know that one of the A's in NASA is aeronautics. So up next, we're going to talk with the project leader of a new type of aircraft. This small experimental plane is powered by electricity. Known as the X-57 Maxwell, it'll help make flying cleaner, quieter, and more sustainable. Let's take a look at this aircraft.
The X-57 Maxwell is NASA's first manned X-plane in almost 20 years. It's a small, experimental airplane that is powered fully by electricity. All-electric airplane technology can make flying cleaner, quieter, and more sustainable.
At this point, throttle is idle, right motor area clear.
With electric power, the X-57 will demonstrate flight that is not only more efficient, but also more reliable, helping to advance the future of green aviation.
So to tell us more about this exciting project, I'm pleased to be joined by the mission's principal investigator, Sean Clark. Sean, how you doing?
I'm great. Thanks for having me.
So this is really exciting. Can you tell us more about the X-57? What is it exactly?
Well, we're seeing a lot of new technologies become available. We're starting to have access to electric motors and batteries that we can use for aircraft design. So on X-57, we're actually putting 14 motors along our aircraft in order to make a vehicle that is much more efficient and uses less energy and has zero carbon emissions in flight.
That's pretty impressive. So it's clear that there's some benefits, but can you talk a little bit more about how the X-57 may help our environment?
Absolutely. So because it's using electric motors and the motors are so lightweight and so much more reliable, we're able to put them in really interesting places on our aircraft. We've got our main motor system out at the wingtips, which actually reduces the aircraft drag and improves performance by reducing the vortex that forms from an aircraft wing. And so along with the high performance wing and our small motors that help us take off and land, this aircraft will use about 5 times less energy for every mile that it travels compared to a typical aircraft that you could buy today.
Wow, it sounds like there's a lot of technological advancement going on. And one of the other things you've mentioned is about the batteries, how to increase, battery development to make it higher voltage. Can you talk a little bit about that process?
Absolutely. We're actually using space station technology from the NASA research on the International Space Station. And by putting that technology in our aircraft batteries, we're able to make a battery system that's safe enough to install next to our pilots, but gives us the energy that we need to perform our experiments. And so that's been really critical, and it's been something we've been able to share with industry already.
And speaking of industry, what do you see as the future of this capability? How large can these planes be?
Oh, what's so exciting about this technology is these motors and these batteries can scale up to larger and larger aircraft. And so our aircraft will hold room for our test pilot and a lot of instrumentation, but these technologies will be able to make aircraft that could carry people a couple hundred miles or across the country if you make a hybrid version in the future.
So NASA conducts many different types of field campaigns, flying airplanes with instruments to look in all different types of environments here on Earth. What about the potential for flying people commercially with this type of technology?
Yeah, it's really exciting. This technology isn't ready to fly commercially right now. You wouldn't want to buy the X-57 because it's an experimental airplane. But our technologies are absolutely applicable to future markets. There's a lot of opportunity for urban air taxis or rural aviation marketplaces opening up due to electric propulsion and aircraft being more accessible to the public. So I'm really excited about it.
So as we're talking about this theme of technological development, do you see an opportunity for this type of technology to be applied for other transportation options, for example?
Absolutely. We're actually using some of the technology from the automotive industry and the railway industry, believe it or not. And so helping to understand how we can adapt those to aircraft and make them lightweight and reliable so that we can use them in flight has been critical. But also learning how to take our software development and flow that back into other industries has been a main goal of ours.
Well, this is just a really impressive project, and I guess my last question is, what excites you most about this inventing and building of technology to really help our home planet?
It's just so exciting to be working on aircraft right now. We're able to take these new technologies and redesign aircraft from the ground up. We're thinking about new and interesting configurations that will make airplanes more efficient and more available to the public so that more people will be able to travel and do it cheaply and with less emissions.
Well, thank you so much for joining us, Sean.
Yeah, thank you.
It's really exciting to hear about the new technologies being developed to create an aircraft completely powered by batteries. Make sure to follow the progress of this mission at social media at NASA Aero. So since its founding in 60 years ago, NASA's been a leading agency known for developing technologies to send people to space, look at the outermost reaches of the solar system and beyond. But did you know that the technologies developed to answer key questions about space exploration and travel have significant benefits for us on Earth? For example, did you know that NASA developed the first computer mouse in the 1960s to interact with data on some of the big first computers? And in the 1970s, they developed memory foam to make pilot seats more comfortable. My all-time favorite, though, is the invention of technology to enable the camera phone in the 1990s, which is now pervasive in camera phone technology and webcams across the world. So to continue our conversation on how NASA technologies can help us here on Earth, I'd like to bring in innovator Annie Meyer. Take a look at some of her and her team's impressive work.
On a one-year mission, a crew of 4 would produce around 2,500 kilograms of trash. I'm Annie Meyer, and I'm turning trash into usable resources. So we're taking that trash and converting it into gases that we can use for either venting off a spacecraft or using it for fuels. So I'm standing in front of what's called Oscar. It not only produces these gases, but it's reducing the trash volume. No one likes to sit in a room surrounded by their trash, and neither do astronauts. And so the things we're studying for converting trash into gases has to be safe for the crew and therefore safe for use on the planet. My grandfather was actually a sanitation worker in the Bronx, and so growing up I was very aware of trash all around us, and I was always curious, how can we reduce our waste or convert it? But I really try to take it home with me and do everything from composting, trying to live as zero waste as you can, show others that if I can do this, you can do it too.
Wow, what an amazing project. Annie, thank you so much for joining us here to talk more about Oscar and answer our questions.
Thank you for having me.
So first, can you tell us more about Oscar?
Sure, we are converting solid trash that you find on a space mission into gas so that we can have a sustainable human presence on space missions.
And so it sounds as if there's a lot of themes within this Earth Day of conservation. How can this technology help improve or affect our lives on Earth?
Yeah, so on a space mission, we think about everything we send up there, and then we have to think about how are we going to use every single drop of what we send up there into something useful. So in our case, we are creating a gas that can be used as a fuel. And if we don't use it as a fuel, we're freeing up space for astronauts and their spacecraft and venting it overboard. So when we think about back on Earth, we always have to think about reduce first. So reduce what you're using before you convert it into something else. And it's a common mindset to try and reduce as much as you can in space.
So there's a lot of technological development here, and one thing I think that's really inspiring is the fact that Oscar is an early career initiative project. Can you talk a little bit more about how you and your team developed this technology?
Sure. So most of the people on our team were engineers or scientists that had never done a hands-on project before or were very early in their career. So we had to take a lean and agile approach and take something from just writing on a piece of paper to a microgravity and suborbital payload in a little under 2 years. So it was very fast-paced, a lot of hard work, but a lot of fun.
So there's a lot of interest at Ask NASA. So we're going to go to social media now where we can talk a bit more about developments of technologies. Katie on Instagram writes, how is the process of recycling different in space than on Earth?
Sure, so the main things I would say are power and time. On Earth, you have people that can spend a lot of time separating out the materials into the different types of materials. In space, we don't have a lot of crew time to separate out the trash, so we need to know exactly what we have up there, exactly what needs to be converted, so we can be as efficient and fast as possible. Also, on Earth, you have a lot more power available to you, and you can spend a lot of energy in your recycling plant. In space, we don't have that, so everything like heating and heating up something or converting it with different sensors has to be done with as little power as possible because it's just not there on a spacecraft. So it makes us very innovative in the approach and the design that we have for this trash to gas reactor.
It's exciting to hear the agility needed and the interplay between scientists and technologists and engineers to really kind of figure out how to advance these capabilities in a totally different environment. Another interesting question from Special K1624 on Instagram asks, what's one of the major changes you've seen from recent technological advancements in your career?
Yeah, so the biggest differences on Earth versus space waste conversion, it's a complicated process on Earth, but in space you have things like heat transfer, fire, and combustion. It's all different in microgravity. So we're spending a lot of time on the physics of fluid flow and heat transfer and things like natural convection and buoyancy. It's all different in microgravity, so it changes the approach of how we design the reactor. But also, we have a lot of harmful gases. If you just throw trash into a fire on Earth, you're going to create some bad gases. On a spacecraft, we need to protect our crew at all costs. So we're trying innovative approaches to make it as clean and efficient of a gas as possible so we're not producing those harmful byproducts. So that's something that we can take back to Earth because Earth is basically a spaceship. We forget that sometimes, but it's this big atmosphere protecting our planet. So the technologies we're using will hopefully go back to Earth and protect that atmosphere from processing our own trash here on Earth.
Well, Annie, thank you so much for joining us. It's been a pleasure talking to you and exciting to hear about the evolution and the developments of Oscar.
Thanks for having me. Happy Earth Day.
Happy Earth Day. So while Annie and her team are working towards innovative ways to manage waste in space and on Earth, our final guest today is looking at how human pressures may be changing our oceans. Using the power of the global community, this NEST research project has developed an interactive app to characterize coral reef ecosystems around the world with unprecedented accuracy. Let's take a look.
What if you could help NASA create a map of the ocean floor with just the tip of your finger? The ocean, teeming with life. It defines our blue planet, drives our ecosystem, and regulates our climate. Coral reefs are one of the most diverse and important systems in the ocean. They're also becoming an important source of medicines for some of the world's deadliest diseases. But they are dying at unprecedented rates due to rising temperatures. But we don't know how much we're losing or how much our climate is changing. We can't until we determine how much healthy reef exists now. And the only way we can know that is with your help. NASA NemoNet is a game where you classify the world's coral reefs by painting on real-life images scanned from the ocean floor using a revolutionary instrument that lets us see beneath the waves at unprecedented resolutions. Our oceans are so vast, it would take us 2 million years to classify the world's coral reefs by hand. The classifications you create are sent to our teams of NASA scientists at home base to teach our supercomputer to classify coral reefs on a global scale. Every contribution you make brings us closer to solving this problem. Join the NASA team to help us understand these amazing ecosystems. Take command of your research vessel and learn about all the different types of coral. We must keep the ocean alive. It supports our life as we know it. Together, we can create a global data set of coral reefs and build a better understanding of how to save these aquatic worlds, one piece of coral at a time. Good luck, and welcome to the NASA NemoNet team.
Wow, what a cool app. Well, joining me now is Ved Chirayath, who's a NASA scientist and NemoNet principal investigator. Ved, thank you so much for being here, and what a great way to engage the public in scientific discovery.
Thank you, Dahlia, and happy Earth Day.
Thank you. Before we talk a little bit more about the app, can you tell me more about NemoNet?
Sure. So NemoNet started in 2016 as actually a way to study and process all of these really high-resolution data sets that an instrument called FluidCam was generating. So it started on the NASA supercomputer, and the challenge grew to how do we process all of these high-resolution data sets of coral reefs from around the world, and that eventually grew into a citizen science app that you can now play.
So what do you find to be the coolest part of this app? What do you hear from users?
For me, this is really just a chance to explore our Earth's oceans like we've never seen them before. Only 6% of our ocean floor is mapped as of 2020, but we've mapped all of Mars and the Moon at a spatial resolution of 30 meters or finer. And it's really surprising because we get so much from the ocean. Coral reefs in particular are just an amazing source of biodiversity on our planet. They support all these life forms in the open ocean that we rely on. And actually, during this viral pandemic, now more than ever, I think about the importance of all the medicines we get from coral reefs. Leading antiviral medications like AZT, which turned around the HIV epidemic, were first discovered in reef systems. So for me, it's exciting because you get to explore and see these data sets coming from our FluidCam instrument, which is the first instrument that's able to peel back the ocean wave distortion and actually map the seafloor in shallow areas at the centimeter scale. And in the game, you not only get to explore these environments, but also color them. And as you color, all of that data gets sent to our supercomputer, which is able to study coral on a global scale by creating a machine learning model with all the training data that users like you provide.
This is an amazing technology. Do you see any other places this could be applied?
Yes, this is actually the first time 3D data has been classified by citizen scientists, and it opens up an entire new way to study the world. Humans rely on our stereo vision, our 3D vision, to separate items out. In fact, if you Google Chihuahua and blueberry muffin, you'll find that this is still a difficult problem from computers to separate out. The faces of Chihuahua dogs and muffins look very similar. But once you have 3D data, you can actually separate those two things out. So for NemoNet, one of the applications we're looking at is going to Mars and the Moon and other planetary bodies and looking for signs of life. On Earth, we actually used FluidCam to study things called stromatolites in Western Australia. Now, these are the first life forms on Earth They've been around 3.5 billion years, and they form these very strange looking rocks. And they're still living in this area in Western Australia. So we were able to map them using FluidCam, and then using a tool like NemoNet, where we train what is considered a living organism and not, we're actually able to separate out the stromatolites, whether they're fossilized or living, from rocks. And that's really a life detection instrument, being able to separate out these 3D structures and identify that they're living organisms, or they were living organisms. So as we venture out into the solar system and the universe, I think what's exciting about NemoNet is that we can bring these advanced 3D machine learning tools to studying different worlds and directing the areas that we want to send our next rovers to.
This is amazing. I mean, we've been hearing throughout the course of the show about how, we can take technologies developed for space and apply them on Earth, but it's really exciting to have the analog on Earth to look into space. So we'd love to take some questions from Ask NASA. And one question is from Shannon on Instagram. What got you interested in coral reef studies?
Yeah, I'm actually an astrophysicist by training, and I met Dr. Sylvia Earle, who you'll see in NemoNet video game. And 2 minutes with Sylvia Earle had me convinced that I needed to point my gaze from the sky down into our own ocean. The amount of information we don't know about something that is so important to us, to me, just makes it an instant switchover. I mean, studying the ocean has been an incredibly fulfilling career so far. I've got to interact with animals and see life in a completely different way. And I hope that everyone playing NemoNet gets that same experience and joy without all of the labors of wearing scuba gear or having to travel to these remote areas and swim and snorkel out to find life forms. But it's a very special place, and you begin to realize that the ocean is really what dominates our planet. And we've lived on this tiny little slice of land our whole lives, but we don't really fully understand how our planet works unless we understand the ocean.
Well, Ved, thank you so much. You've definitely inspired me. And how can others be inspired and get involved with the app?
So I encourage everybody to get involved in the app and also in your community. You can download the NemoNet app in the App Store right now for desktop and iOS devices. And you can also visit our homepage at nemonet.info.
Great. Well, thank you so much, Fed, for joining us. So that's about all for our show today. Thank you so much for joining us on today, the 50th anniversary of Earth Day. If you want to find out all the ways you can get involved, please visit nasa.gov/Earth Day. NASA has launched a NASA at Home website where you can find lots of different resources, videos, podcasts, and activities to learn more about NASA's exciting technology and science. Also, follow the hashtag Earth Day at Home for a schedule of activities in honor of Earth Day. Thank you so much for joining us, and we hope to see you next time.